Good morning, dear students. Today we will have one of the CET shortcut methods, that is integration of greatest integer function short trick I would like to introduce. But before I could introduce the short trick, let me start with the example. Say for example, if you have, say, assume first one, integration from 0 to 5, greatest integer function of x dx. You know the answer is add all the integers starting from 0 till the integer which is less than the upper limit. So here I will tell you once again, add all the integers starting from 0 continuously till the integer 1 less than the upper limit. Therefore, upper limit is 5. So, 1 less than 5 is 4. So, I should add the integers starting from 0 continuously, all the integers, then 1 I should add, plus 2, plus 3 and plus 4. This is 4 is 1 less than the upper limit 5. Therefore, this becomes the answer for this definite integral. I would like to give you one more example. Look at this. Integration from 0 to, say, I would take 9, greatest integer function less than or equal to x dx. So the trick I said, the short trick I said, add all the integers starting from 0 continuously till the integer which is 1 less than upper limit. So therefore, starting from 0, add all the integers 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Till 8 I have to add because upper limit is 9. So 1 less than upper limit 9 is 8. So I have to add this much and this answer becomes 36. But now come to the short trick. Sometimes if the upper limit is very large natural number, very large positive integer, we may think that the method is a bit lengthy, complicated, very tedious, okay, because adding all the integers starting from 0 continuously till the integer 1 less than the upper limit is becoming a lengthy task. In that case, I would like to give the short trick now. Say, dear students, you please follow the short trick now. That is integration from 0 to n, where n is a natural number, and in fact assume any natural number, greatest integer less than or equal to x function dx we have. Answer is n into n minus 1 divided by 2. This is the short trick. This I request you kindly memorize as a formula. When I say kindly memorize as a formula, a few students may feel it a little bit uncomfortable. They may think that memorizing this as a formula may be also difficult unless we know the proof. Therefore, those who are interested in, I will tell you the shortcut to get this formula. You know, integration from 0 to n, greatest integer of x less than or is equal to x dx. Now, what is the trick I said? I said starting from 0, add all the integers continuously till the integer 1 less than upper limit. Therefore, 0 plus 1 plus 2 plus 3 plus so on plus and the one upper limit is n. 1 less than upper limit n is n minus 1. So this And this sum, ignore 0. 1 plus 2 plus 3 plus so on plus n minus 1 is the sum of the first n minus 1 natural numbers. And if you use the sum of n terms of an arithmetic progression formula, this sum will result into n into n minus 1 divided by 2. So I would request you to go through this short trick. So here is the short trick. Integration from 0 to n, greatest integer function less than or is equal to x dx, and answer is n into n minus 1 divided by 2, where n is a natural number. To understand this formula better, say for example, I would like to give this one. Say, suppose this appears. Assume integration from 0 to 21 and the greatest integer function of x dx. Then your answer is, say, compare the formula with the given question. Say n is 21. Therefore, where n is there, on the right hand side as well, I will put 21. 21 into 21 minus 1 divided by 2. So 21 minus 1, 20 by 2, 10. So 21 into 10, so answer is 210. Or one more example, in case they ask this, integration from 0 to 100 of greatest integer function of x dx. Say here n is 100. So 100 into 100 minus 1 divided by 2. 2 goes in 100 here 50 times. So 50 into 99. I would request you, please do not use calculator at any stage of your CET preparation. Then 50 into 99. How can this be multiplied easily? One trick is you multiply 99 to 0. It is 0. Then 99 to 5. You may find difficult. You go for 100 into 5 in your mind. 100 into 5, 500. From 500, I want 5 less because I want to multiply 99 into 5, not 100 into 5. So 100 into 5, 500. From 500, remove 5. So it becomes 495. So that is here on the side. So this kind of examples we will see from the earlier CET papers. Kindly go through. Students, here is a question from KCET 2012. If this is the greatest integer function, not greater than x, that is less than or is equal to x, then integration from 0 to 11 of greatest integer function of x dx is equal to. I request you, using the trick that I have given here, please solve this. Yeah. Okay, I assume you have completed. Now just listen here. It is integration from 0 to 11 of the greatest integer function of x dx. And the value of n is 11. So our n value 11 into 11 minus 1 divided by 2. So 11 minus 1, 10. So 11 into 10 by 2 is 5. So answer is 55. So therefore option D is correct to this question. Also, I would like to mention, yes, using this formula you got the answer correct. In case you forgot the formula, then I told the earlier trick, that is if the upper limit is a little bit smaller number. Yes, 11 is not that bigger number, a little bit smaller number. So you have to add all the integers starting from 0 till the integer 1 less than 11. That means starting from 0, 0 plus 1 plus 2 plus 3 plus so on, last plus 10, 1 less than 11 is 10. Therefore kindly go through the answer. Here is the next KCET 2022 question. Same greatest integer function question, but upper limit is 8, and I would request you to solve this first. Okay, fine. Now, let me solve integration from 0 to 8 of this greatest integer function of x dx. So, n is 8 here, 8 into n minus 1, 8 minus 1 by 2. 2 goes here 4 times, 4 into 8 minus 1, 7, so 28. Therefore, this question, option B is correct. Now, kindly check your answer. Dear students, here is a slightly different question. Function is the same, greatest integer function less than or is equal to x, but limits you can see rational numbers. 0.3 is the lower limit, 4.5 is the upper limit. Lower limit is not 0. So I will tell you the short trick to solve this type of limits or this type of integrals. You have to start adding from 0. That is, lower limit is 0.3. Please take the previous immediate integer, that is 0. Then keep on adding 1 plus 2 plus 3. Then don't think that we have to stop at 3. No. Or don't think that we have to add 4.5. No, not that also. Then we have to add the integer 4. That 4 is the integral part of 4.5. And this 4 is added here, right? This 4 should be multiplied by, only number 4 should be multiplied by the fractional part of the number 4.5. That I will show you in the rough work side. So we have 4.5. This can be split as 4 plus 0.5. Therefore, this 0.5 or 5 by 10, this is the fractional part of 4.5, and that has to be multiplied to the number 4. Therefore, this sum becomes 1 plus 2, 3 plus 3, 6 here, plus 4 into, 0.5. We can write directly 1 by 2, or you can write 5 by 10. Okay, I will write 5 by 10. And thus it becomes 20 by 10 2. Therefore, final answer is 8. I will show you one more exercise of the same variety where the lower limit is assume 0.7 and upper limit is assume 8.9 of the greatest integer function of x dx. What I said, look at the lower limit 0.7. Go to the previous immediate integer, that is 0. So start adding from 0 and keep on adding till 8. Even 8 should be added. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 also should be added. 8 is the integral part present in 8.9. But the last number 8 you have added. To that number you multiply by the fractional part of 8.9. So fractional part of 8.9 is 0.9. Say, I will write here. We have 8.9. This can be split as 8 plus 0.9. So this becomes the integral part. This is integral part or integer part. This is fractional part 0.9, or this 0.9 I can also write as 9 by 10, as all of you know, that fractional part should be multiplied only to 8, last number. Now look at the sum. It is 3, here 6, 10, 15, 21 and 28. So it is 28 plus 8 into this 8 into 0.9. As I said, I will write 9 by 10. And this we can simplify. This here 2 goes 4 times, 2 goes here 5 times. So 4 into 9, 36. 36 divided by 5 here. So 28 plus, you can write 36 divided by 5. So 5 goes 7 times, 35. Then there is 10. So it is that for 7.2. So it becomes answer 35.2. Kindly go through this shortcut idea as well. Here is a question from KCET 2017. Say lower limit 0.2, upper limit 3.5 of the same greatest integer function dx is equal to, and the shortcut that I explained. Say integration from 0.2 to 3.5 of the greatest integer function of x dx. Start from 0, adding 1 plus 2 plus. We have to add even the number 3. 3 we have to add, integer part. And this 3, the number we have added, that number multiply by the fractional part of 3.5, which I write in the rough work side. Say 3.5. It's fractional part is equal to 0.5, which is nothing but 5 by 10 or half directly. Therefore multiply by 5 by 10. Therefore this answer becomes 3 here. This is 15 by 10. Say 3 plus 15 by 10. And 15 by 10 is 1.5. 3 plus 1.5. So 4.5. Hence this question, option A is correct. Kindly go through. So dear students, I hope that you have understood this CET video and this short trick what I explained in this video. Still, if you are not subscribed my videos, kindly subscribe the videos, also share with others, also give like and watch the videos continuously, and in future also I will be conducting more of the shortcut methods in CET, and those videos will be available to you. So thank you. Kindly go through the video.